This is one of my favorite chapters, chapter 4, because this is where we get to predict what happens when reactants become products. We can make a prediction as to what the product's going to be. So one of the things we have to be able to predict is looking at a compound and figuring out whether it's going to break apart in water to form ions and become an electrolyte. So when I look at A, it's a carbon, hydrogen, oxygen compound, right? Carbon is the black ball, and the red one is oxygen, and the white one is hydrogen. I end up with this is a molecule. This is formic acid, all right? So that white one attached to the red one is an OH group, and we have a double bonded O attached to the central carbon. So what happens is the electrons get pulled towards that O, and that weakens that bond between the H and the O, and that H pops off. So formic acid, as the name implies, is an acid. If I put it in water, it will ionize to some extent to form H plus ions, but not very much. All right, so it's a weak acid, right? To figure out whether you're a strong acid at this point in the course, you just have to memorize that we have 7 or 8 strong acids and memorize their formulas. Formic acid isn't one of our strong acids, so it's a weak acid. You've got 3 oxygens attached to a central nitrogen with an H attached to one of the O's. This is nitric acid, and nitric acid is one of our strong acids. So that means when we put it into water, it's going to completely ionize to form H plus ion. So it is a strong electrolyte. Ethanol, the OH group that's attached to that carbon, that bond isn't weakened by some double bonded O. So that H on that OH group isn't going to pop off. Neither will the H's attached to the carbons. So this is a non-electrolyte. You put this into water and there's no ionization, barely any ionization. So it's the same as water. It's a non-electrolyte. All right, as we just said, formic acid is a weak acid, which means that when I put it into water, it breaks apart to form formate and H plus ion. So like I also said, that H plus ion will reattach once the concentration's gotten great enough that it can find a formate. It'll find that formate and reform the formic acid. So with formic acid, you're basically floating around in the water. You basically have 99% formic acid and very little 2% formate and H plus ion. So very little ionization with this species. So very little H plus ion floating around the water, very little formate. Right, another name for an H plus ion is a proton. And we use this symbol of a double arrow when we have a reversible reaction, meaning that the reaction can go in the other way. H plus ion reattaching to the formate to reform the formic acid. This is called equilibrium, and we'll get to it toward the end of the course in a lot of detail. So at this point, just realize if it's a reversible reaction on a weak acid, it's because the H will reattach to the anion to form the original acid. I just put this in same reaction, but instead of looking at it as breaking apart to form H plus ions, we're looking at it in terms of the protonation of water. So there's 2 ways, right? An Arrhenius definition of an acid, a Bronsted definition. In the Bronsted definition, water is acting as an H acceptor and formic acid's acting as an H donor. So the H gets donated to the water to form hydronium ion and formate. So either way you look at it, right, it's a definition of an acid, right? An acid interacting with either protonating water to form hydronium ion or breaking apart to form a protonated H plus or a hydrated H plus ion, H plus ion floating around in water. In reality, this is, or I should say, this is closer to reality, the formation of the hydronium ion. All right, will a precipitation occur from the following reactants? All right, so we use solubility rules to figure out whether precipitation is going to occur. So I have aqueous sodium carbonate, sodium ions, carbonate ions floating around, silver ions, nitrate ions floating around. The question is, when when a cation finds the other anion, will it drop out and form a precipitate? Well, if you look at the rules for nitrate, nothing is going to precipitate in nitrate. Whereas most of the time, carbonates precipitate, with the exception of ammonium ion and alkali cations. So when that carbonate finds that silver ion, yes, you're going to get it dropping out and forming a precipitate. We have to balance this. Right? We have 2 sodiums going in, so 2 sodiums have to coming out. 2 nitrates going in, 2 nitrates coming out. All right, looking at this in terms of, I guess what, on a submicroscopic view, right? We're looking at the ions in solutions. What happens to those ions in solution? The silver ion and the carbon ion find each other. When they find each other, they'd rather surround each other than be floating around in water. So this is what it means to precipitate. They drop out and form a solid. Whereas the sodium ions and the nitrate ions don't do anything. They went in the same way they come out. So this is what's known as being a spectator ion. You're not involved in this reaction. This reaction is between the carbonate ion and the silver ion. This is the net ionic equation, right? We're omitting the spectator ions. They're not part of the reaction. All right, looking at B, will sodium nitrate precipitate nickel sulfate? Look at the rules. Hey, all the time nitrate is soluble. Now, sulfate's soluble most of the time, with the exceptions of strontium, barium, mercury, and lead-2 ion. When I look at what it's matched up with here, it's matched up with sodium ion. So no, anything with sodium ion is going to be soluble, and nickel will not precipitate nitrate. So this is a non-reaction. You put these soluble ionic compounds together, nothing's going to happen. They won't precipitate. All right, for C, you've got iron 2 sulfate reacting with lead 2 nitrate. So the question is anything going to precipitate here? When I look at the rules for nitrate, nothing will precipitate. But when I look at sulfate, anything with if it matches up with a strontium, barium, mercury, or lead 2 ion, it's going to precipitate. So when the lead ion finds that sulfate ion, yeah, that's one of our exceptions to sulfate. It's going to precipitate. That's my dog.